All right, let's take a look at our spicy example. Notice the list of instructions here hasn't changed. We still want to start by simplifying, but unfortunately, now I have different indexes for these three terms. I've got two of them with an index of 4 and one with an index of 3. So we actually need two columns on our cheat sheet here. We don't use that fourth column very much. So when it shows up, it is sometimes a bit of takes you back a bit. But no big deal, we can still handle this. When we're looking at those fourth roots, that means we want to find perfect fourths in order to break down these radicals. So 48 you can break up into 16 times 3. And conveniently, 3, the 3 in the middle here, we don't have a perfect fourth factor other than 1. Breaking it up into 1 times 3 doesn't help us a whole lot. So we only really have to worry about simplifying one of these two fourth roots. So the fourth root of 16, again, if you're not comfortable saying that or thinking about that one in your head, please use the cheat sheet. That's what it's here for. The fourth root of 16 is going to be 2. The fourth root of 16 is 2. So we get a 2. The fourth root of 3 is not a nice number, so it just comes along for the ride. And like the previous two examples, we don't want to lose the 7. So we can clean that up in a second. Next thing I want to do is bring down this middle term. The whole thing, we can't simplify that one, so it's just coming along for the ride. Last but not least, we have the cubic term we can take care of. This cubic term, nice try, Arrow. We do have to do a little bit of work. That 72 is not a perfect cube, but we can look for a perfect cube factor. In the cube column, notice you try 64. 64 is not going to work. 72 divided by 27 is not going to work. But 72 is divisible by 8. So we can break that 72 up. That is a third root of 8. And 8 times what? Well, 8 times 9. 8 times 9 gets you to 72. So we can clean that up a little bit. The cube root of 8 is a 2. Cube root of 9 is not a nice number, so it's just coming down. We want to be careful there because the square root of 9 is 3, but the cube root of 9 is not something nice. So we don't want to get our square roots and our cube roots mixed up. Again, I highly encourage you to have this cheat sheet out with you while you're working through these problems. We don't want to lose this coefficient either. There was a 3 in front of that radical and an addition. So there's quite a bit going on in this problem, which is why this is our spicy level example. We can certainly clean things up here. 7 times 2, that's a 14. Fourth root of 3 is tagging along for the ride. We still have the minus 2 fourth root of 3, and then 3 times 2 is 6, cube root of 9. So in order to combine radicals, we need to have the same radicand and the same index. So those instructions are at the top of those guided notes. In order to combine them, we need both things, both the radicands and the indexes. So we can really only put 2 of these together. 14 fourth root of 3s and 2 fourth root of 3s. You have $14 and somebody takes 2 of them away from you, sorry, you only have $12. Unfortunately, instead of dollars, we're working in fourth root of 3s here. But we can combine those two radicals. The other one, the 6 cube root of 9, is not a like radical, so there's nothing that we can do. Now this problem is a bit more difficult than many of the ones we'll see moving forward when we actually start solving equations. We don't see fourth roots too often, but occasionally we will have radicals that are not like radicals, so final answers will look like this. There'll be 2 different kinds of radicals hanging out, whether there's a square root of something and a cube root of something, or just 2 square roots that don't match up. So we want to get used to seeing binomials as final answers here. That's all for the spicy example. Time to try some Math Excel.